speak about the function and the relation between the mathematic and function group, which is the relation between the y-axis and x-axis. When directly there is a relation between the y and the x, for example, y equal ax plus b, in this case, the, the function will be linear, which the 3 will be y-intercept and minus 1.5 is the x-axis. Okay, it's very easy because if you see here from those 2 points, we can find the relation between the function and also relation between the x and y-axis. Okay, but as you see here in this graph, we can find the slope is 2. The slope 2 is the as you see here, there is a relation between the y-axis and x-axis. It is a tangent alpha, which equal delta y per delta x. It is a alpha slope. As you see here, I can show you a slope here. Okay, as you see here, it is alpha. As you see, it's a tangent alpha. It is a delta y per delta x. It is equal 4 per 2. And then slope will be 2. As you see in this graph, we can find the slope very easily. How we can find, for example, from the graph, we can find x-intercept. We can say the graph is the y equal 2x plus 3. If we put 0 in the y-axis, 2x plus 3, in this situation, we can find the x minus 1.5. Okay, and this point will be x-intercept. Okay, and if also we can use from formula y minus yr equal slope multiply x minus xr. From 2 points, we can find also the equation. As you see here, it is very easy. We can find the relation between the y-axis and x-axis, and from here we can find the equation also. For example, I drew the new graph. For example, y equal 3x minus 4. This is a graph, okay? It has a 2 intercept, okay? It's a y-intercept and x-intercept. As you see here, this graph has a 2 intercept, but better we can change to the it with for the 5 because the number is not good. Maybe in this case y-intercept is not also good. Maybe it is also changed to the 6. Okay, I think it is good. Now it's best. Y-intercept is the minus 6, 0 minus 6. X-intercept is 2, 0. Now with this 2 point or other point, for example, every point, I can find equation. For example, I want to use fit this formula. There is a very new, very good formula. The name of the formula is start y okay y minus ya divide x minus xa equal yb minus ya divide xb minus xa. And I can put the number here, y minus. I can put a is the ya is the 0 for this point, and x minus for this point is the 2, and equal b is the minus 6 minus again 0, and for the xp it is a minus, it will be 0 minus, and xa will be 2. Okay, in this case we have y divided x minus 2 equal 3. It's very easy. I can find here 3x minus 6. The equation is very easy. We can find with this new formula. From the both sides we can use this one. The other things we can use, the other formula we can use, we can find from slope. As you see here, slope here equal delta y per delta x. It will be 3 per 1. It is a 3. Okay, and I can use a new formula. Y minus ya is equal slope multiply x minus xa. Y minus 0 for point A equal slope is 3, x minus xa is 2. In this case, y equals 3x minus 6. As you see here, with the point, we can find also, with the help of slope, we can find the equation. The other function is the parabola. In the parabola, there is a relation between the y and the x in the power 2. You see, as you see here, the y equal x power 2. As you see here, it has a minimum if we have a x power 2 is the positive, and if we have a sign of x power 2 negative, in this case will be maximum. Okay, it's very easy. Okay, when for example we have this equation, we can draw other equation. For example, y equal parenthesis, okay, x plus 1 altogether power 2. As you see here, when we have equation inside the parentheses, okay, we have a number. If it is positive, in this case, the graph will be shifted to the left. Okay, as you see here, this graph, very easy, and as you see here, it will be shifted to 1 to left. But if we have a, for example, if not, we put the same graph, but without this parentheses. In this case, as you see here, plus 1. In this case, because of outside, the situation shift to up. In this case, without parentheses, the numbers related to the move to up or down, if the positive up or if the negative is down. As you see here, for example, if I put plus 3, the graph will be 3 move up. Okay, as you see, it's very easy in this case, and we can understand very late. Also, we can have a both of them. For example, I draw the same graph with the two number. You see, if you see here, 1 plus 1 inside the parentheses, minus 3 is outside the parentheses, then 1 shifted to the left, and 3 shifted down. Okay, and minimum point will be minus 1 and minus 3, and for the first graph is the 0, 0. How we can find minimum point for this equation? It is very easy. Minimum when the derivative of the function equal 0. For example, if we have a first graph or second graph, okay, we have a first graph, okay, it is y equal x power 2, if the then derivative of the y per x equal 2x equals 0, x equals 0. After, if we put x in the 0, will be epsilon equal y is equal 0. In this case, minimum will be like this. But when we have an equation like this equation, y equal x plus 1 power 2 minus 3. Okay, in this case, if we have a derivative of this equation, or dy per dx equal 2x x plus 1, okay, and if we put equal 0, x equal minus 1. And if we put a minus 1 in the graph, it will be minus 1 plus 1 power 2 minus 3, y equal minus 3. Okay, this will be our minimum. Okay, it's very easy how we can know it is a minimum, because if we put the number before and this after that, the sign of this number will be positive or negative. It will be, or we can make a graph or the table. Okay, for example, I can make a table. Okay, the number x, for the x I have a minus 1, and I have a f prime is the derivative, it will be 0. Okay, you see the derivative to x plus 1. The right side will be, as you see here, will be the same sign of the 2x, it is a positive, and the left side will be negative. In this case, after minimum can be positive, it shows increasing function, and before it will be decreasing function. It's very easy. For example, if you want to find like this graph, I will can explain very easily. For example, if we have a y equal minus 2x power 2 plus 3, okay? As you see in this graph, we can find every information with the graph very easily without do anything. We can find the min maximum, and also we have a 2 point which is the root. How is it possible? Minus, we can find from here to find of the x-intercept. Okay, for example, if we put f prime x, fx equals 0, and the meaning is y is equal 0, equation with the points we can find in this one, x1 and x2, is will be x-intercept. These 2 points is very important. Okay, as you see here in this equation, we can find, for example, if you see here in the graph, minus 2x plus 3, minus 2x plus 3, if I want to find it equals 0, minus 2x plus 3 is equal 0, and in this case 2x2 equal 3, x2 equal 3 point per 2, and equal radical 1.5, which can be positive and negative. This point it will be positive radical 0.5, and this point is the negative radical 1.5. As you see, this is the x-intercept, and y-intercept when we have x equals 0, but here it will be the same as the maximum. It's very easy and very understandable. Okay, the other graph, when we have a graph in the power 3, for example, when I have a power 3, okay, in this case, we can have a maximum and minimum. For example, if you see, for example, this graph, okay, plus 2, okay? As you see here from this graph, we can have a maximum, okay, and a minimum also. And also we can have a, okay, inflection point between these 2 points, okay? As for finding this equation is very easy and also very nice. If we can find equation x3 minus x power 3 minus 2x2 plus 2. Okay, if I want to draw this equation, okay, and in this situation y equal x3 minus 2x2 plus 2. As you see, the same equation. Okay, and first, for find of the maximum minimum, we can say f prime x equal 0. In this case, derivative will be 3x2 minus 2x equals 0. We can make a factor from x. X equals will be 3x minus 2 is 0. X will be 0, and also will be positive 1.5. Okay, we have these two cases. Excuse me, it will be minus 4x because of the derivative, minus 4, and it will be positive 4 per 3, 1.33. Okay, in this case, if we put a 0 for the function, for the first function, it will be positive 2. And if we put 1.33, and we can find x around 0.8. Okay, as you see here, we have a maximum and minimum. It is very easy and very nice. And if we ask second derivative, it will be 6x minus 4x equal 4 per 6 or 2 per 3, and it will be around 0.66, and in this case will be like here will be an inflection point. Okay, and it's very easy for this case if we want to find the minimum and the maximum from the graph, and it's very easy. Okay, and we can find this mathematically, how we can calculate this equation from this type of the graphs. Sometimes we cannot calculate, we cannot find the root of the function. For example, if we have a function 3x power 3 plus 2x 2 minus 4x plus minus 4. Okay, it is hard to find the root of when this equation equals 0. Okay, it is very hard. But in the graph, we can easily find this equation, because when we use a graph, okay, for example, when we use a graph, for this graph, I can find how is it possible. Okay, for example, I write y equal x 3x power 3 plus 2x power 2, okay, plus 2x power 2 minus 4x minus 4. As you see here very nicely, this point will be the answer, our answer. In this number, we can say this equation has just one number where it is equal 1.225. Sometimes it's hard to calculate or find the mathematically root of the function for when the x can be 0, this equation can be 0, but with the graph we can find it. Also from here we can find the maximum and the minimum and y-intercept. Okay, for example, if we put a minus 4 in this situation, this equation will be 0. Okay, it's very easy and very nice. And when put minus 4 in this equation, for the y, in this case x will be 0, or if we can put a 0, and the result will be minus 4. Okay, and like other part, I can also use the derivative of this equation will be 9x2 plus 4x minus 4. If they equal 0, in this situation I can find x root and the 2, and equal minus b plus minus b power 2 minus 4ac divided 2a. In this equation, we can find those two roots, maximum and minimum. And if we again derivative from here, if the second derivative will be 18x plus 4, and x equal minus 4 per 18. And it will be very small number around here. It will be inflection point. It will be very easily. And how we can find this relation? We can use this very beautiful graph. Yeah, right. Fx, f prime x, f second x. Okay. For example, when we have a three graphs, in this case, we have a several number. When the inflection point is the zero, for example, r is the zero, the equation will be right, positive the sign, and the left is the negative the sign. When the inflection point is the zero, it is a maximum and the minimum. Okay, and from this sign we can find how is the graph go up, go down, go up again. Okay, and it will be positive, negative, negative, positive. How is it possible? These two lines, it will be concave down. And when this is positive, then concave up. And this shows these two parts concave down, and these 2 points concave up. Okay? Then usually when we make a graph, this shape of the graph will be like this. Here is the concave down, here is the concave down. After inflection point, the concave will be up. It is very easy, and we can find very nicely this type of the graph. Okay, and we can say how this function work. Okay, and finally from this equation we can classify this rule. It is very important. When we have a fx, a function of fx, f prime x equals 0, okay, usually it can show us the maximum or minimum. And when we have a second derivative, usually inflection point. When we have fx equals 0, it will be y-intercept. And okay, when we have a f prime x, it is a x-intercept. And when we have a x equals 0, in this situation will be y-intercept. For example, if I have a graph like this, in this case, this 2 point f prime x equals 0, f prime x equals 0. And for here, f second x equals 0, second derivative is 0. Until f prime x equals 0, it is the positive sign is increasing derivative, and then decrease derivative, and again increase derivative. It's very easily we can understand how we can work about these equations, how they related to each other, and how it can work. Mainly we can do like this in the graphs. The last part, for example, if we have the big graphs, for example, in the powers, for example, when I have a equation y equal 2x power 5, okay, plus 2x minus 3, okay. As you see, the graph change. If we increase the function as a power, big power, as you see here, graph will be more wider, okay, because also when we find the function, we can find more here. If you see here, more related the number close to the x-axis. You see, if I make it bigger and bigger, in this case you see it will be very closer to x-axis, but it's not x-axis, because as you see, it means when we have a power is so big, for example, y equal 2x power 8. As you see here in the when it has a even and odd, but I can use, for example, this time is 9, as you see, more wider, because in this case, if we put very small number for the x, and almost y will be equal closer to the 0. And also it is a good part. In this part I can say you, if for example use a even number, for example 8 will be like a parabola but in the big function. It's very easy, and we can find from this equation how we can find relation between these two and how we can find calculate it. The last part, when we have a two line, for example y equal 2x plus 3, and also we have a function y equal minus 3x plus 4. Okay, as you see here from this equation we can find intercept between two line, interaction point. It's very easy when we equal this equation, equal each other, and also we can have the x-intercept for both line, and we can also y-intercept. In the next lecture we can study about how we can calculate the area under the graph between the two equation and the one and the axis, for example x-axis. And I believe we can learn how we can possible for this equation, and for the finding of the interaction point or the same graph for intercept. It is easily just we the two function can be equal in the 2 x plus 3 equal minus 3x plus 4, and it is very easily we can find the x, and this x will be 0.2, and if we put in the both of the graph 0.2, the 3.4 will be our answer for the interaction point between two graphs in the y-axis. I hope this lecture will be very nice about mathematics, and I hope next time I will speak about more about area under the curve, and mainly we will go in the effect of the differentiation and integral in the graph, and I hope it will be useful for you, and see you in the next lecture. Thank you.